In section 8.2, we're going to take a look at properties of parallelograms. And obviously, section 1, we looked at polygons in general. We looked at interior angle sums and exterior angle sums. And so now we're going to shift gears and look at specific quadrilaterals. And really, this is where our attention is going to be paid for the rest of this chapter, is using different types of quadrilaterals, starting with parallelograms here. So by the end of today, you should know not only what it means to be a parallelogram, but also what is unique about a parallelogram. What properties does a parallelogram have? All right, and so essentially, the first thing is the definition of a parallelogram. Okay, when we tell you a quadrilateral is a parallelogram, all that means is that the opposite sides are parallel. Okay, in other words, in this diagram, these two sides are parallel, and those two sides would have to be parallel to each other to be a parallelogram. Okay. Now we're going to get into the properties. Okay, and I know it says theorem 8.3. You don't have to memorize any of that. Okay, it's just letting you know where this is coming from in your book. Okay, the first property out of 4 that is unique about a parallelogram is that the opposite sides are congruent. All right, so as soon as we know that this figure down here is a parallelogram, we know that RS is congruent to PQ. Remember, opposite sides are congruent, and QR is congruent to PS. Okay, pretty straightforward. So again, parallelogram, opposite sides are parallel. Once we know it's a parallelogram, then automatically the opposite sides are also congruent. The second property you need to know is that the opposite angles are also congruent. Okay, so in this particular diagram, angle P would have to be congruent to angle R, and angle Q would have to be congruent to angle S. Okay, so again, parallelogram. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent. There's no way around these properties. You just got to take the time to memorize them, and you'll be fine. Okay. The next theorem, this next property is one that is going to take a second for you to really realize. It says that the consecutive angles are supplementary. In other words, if I start with this angle, I can go in either direction. I can go right or left. If I go to the right, then I'm talking about those two angles. Angle P and angle S are supplementary. Okay? Angle S and angle R are supplementary. Angle R and angle Q are supplementary. Angle Q and angle P are supplementary. All right, so that means they add up to 180 degrees. Well, Mr. Cook, how do we know they're supplementary? If you think back, we looked at in first semester, we had parallel lines that were cut by a transversal, okay? And there was a unique relationship between consecutive interior angles. Specifically, same side interior or consecutive interior angles are supplementary. Okay, well, that's exactly what we're looking at in a parallelogram. Okay, if I just erase this, and again, we know that these two sides here are parallel. Whoops, nice job, Cook. So we're looking at this. If I know these two sides are parallel, then these two angles are supplementary. So this portion of this diagram is the same as this portion of a parallelogram. Okay, so that's kind of where that theorem comes from. Just a quick thing to note there. And then the last property we're going to look at involves the diagonals. Diagonals just means you go from one vertex to the opposite vertex. All right, so obviously RP is one diagonal, and then QS would be the other diagonal. And the unique relationship here is that the diagonals bisect each other. Okay, diagonals are not the same length, but they bisect each other. So in other words, this diagonal here, this PR, cuts QS in half. And by the same argument, QS cuts PR in half. Okay, so those two pieces have to be congruent. So in other words, QM is going to be congruent to MS, right? It's cut in half. And then PM would be congruent to MR in a parallelogram. So 5 primary things you need to know. A parallelogram, opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. I know right now it's probably a little bit overwhelming, but hopefully by the end of the day tomorrow you'll feel a little bit more confident in parallelograms or properties of parallelograms. So example 1 here, The gate has several parallelograms. Find the measure of angle ADC when the measure of angle DAB is 65. So DAB is 65 degrees, and our task is to find the measure of ADC. I'll mark it in red here so we know. And then you ask yourself, well, what relationship does this angle have with the 65? Okay, are they opposite angles or are they consecutive angles? They got to be one or the other. Okay, they're consecutive angles. Once you identify their consecutive angles, then you know that the measure of angle ADC plus 65 has to equal 180, right? Consecutive angles are supplementary. And now it becomes a simple algebra problem. Subtract your 65 from both sides. So the measure of angle ADC here in this first diagram happens to be 115 degrees. All right, so again, identify the property you have to use and then use it. That's all we're doing here. Excuse me. Example 2. Says find the values of each variable in the diagram. So again, you look at the diagram and you say, okay, I'm given this angle. I want to know this angle. Relationship, consecutive angles. Consecutive angles, supplementary. 2x, 42, 180. Okay, supplementary means they add up to 180. Subtract both sides from, by 42. And so you end up with 2x equals 180 minus 42 is 138. Divide both sides by 2. So your final answer here is x equals, what is that, 69? And that would be your final answer there for the value of x in that first diagram. Okay? Again, my encouragement to you would be to pause the video, try these examples on your own, and then go ahead and play the video or fast forward just to make sure that you did it correctly. Okay. Example 2, part B. Again, we got to solve for x and for y. It doesn't matter which one. Pick one and solve for it. So I always solve for x first. It comes first in the alphabet. So I have x plus 6. All right. And I know the side across from it is 13. You go back to your properties of a parallelogram. Opposite sides are parallel, but opposite sides are also congruent. Therefore, that tells us that x plus 6 has to be 13 units long. Subtract 6 from both sides. So x has to be 7 here. Okay, opposite sides are congruent. By the same argument, or similar argument, I should say, if I know this angle is 68 and I want to know why, well, again, these angles are opposite of each other. Therefore, they have to be congruent. Okay, opposite angles in a parallelogram are congruent. And finally, part C, there's our diagram, solve for x and y and z. There's actually z in there as well. And this kind of incorporates just about all of the properties except for one. So again, same process. 2x minus 3 and 37 are opposite sides. Therefore, 2x minus 3 has to equal 37. Add your 3's. So you get 2x equals 40. Divide by 2 on both sides to get x by itself. So x equals 20 here. Okay. Again, you go back to y. Well, that's 123, and y is opposite. Therefore, y has to be 123 degrees. You don't really have to do any work there. You're done. They're opposite angles. They got to be congruent. And then you look at angle z. All right. And this angle is 123. Well, z and that 123 are consecutive angles. So z plus 123 have to be 180. They have to be supplementary. Okay, so you subtract the 123 from both sides, and that tells you that z here has to be 180 minus 123 should be 57. All right, so there's just another example of using these properties of a parallelogram to solve for variables. All right, moving right along here. Now this is the only property that we haven't used yet in solving for a problem. So it says, given that this shape is a parallelogram, find the measure of MH and find the measure of FH. Okay, well again, it goes back to these guys are diagonals, therefore they bisect each other. Okay, well if this piece is 5, this piece has to be 5. So MH is just 5. And FH is the whole thing. 5 plus 5 is 10. Again, not a very difficult problem there because there's no algebra involved. Okay, when you got variables, it makes it a little bit tougher. Okay, it says find the coordinates of P if this figure here is a parallelogram. Well, think about it. If it's a parallelogram, diagonals bisect each other. Okay? And if you think about that, if they bisect each other, then that means that this point right here is the midpoint of D and B, and it's also the midpoint of A and C. So really, this turns into a midpoint problem. And some of you may or may not remember the midpoint formula. If you recall, to find the midpoint, you do x1 plus x2 divided by 2, y1 plus y2 divided by 2. I like to think of it as just average your x coordinates and average your y coordinates. So when I do this, it doesn't matter what I want to find the midpoint of. I'll find the midpoint of BD. So I'm going to find the midpoint of BD. That's how I'd make note of that. And so I average my x coordinates. So I have 5 plus negative 3 divided by 2. And I have 6 plus negative 2 divided by 2. And now I just simplify. 5 plus negative 3, this is 2. 2 divided by 2 tells me the x coordinate's 1. And finally, 6 plus negative 2, that's 4. 4 divided by 2 is 2. Okay, so that right there would be the coordinates of point P. Again, diagonals bisect, therefore the point where they intersect is the midpoint. Turns into a midpoint problem. And this particular problem is pretty extensive here. I'm actually not going to take the time to do it. But I think it would be a great way for you to go through. This pretty much incorporates just about every property that we've discussed. So work through this last example. First thing we'll do in class tomorrow is take any questions on it. We'll go through it, make sure you're all good to go on this particular type of problem, and then we will get rocking and rolling with additional examples throughout the hour. So again, any questions as usual, bring them to class, have them ready, and we'll take those first thing tomorrow.